Okay, class, picking up where we left off at. The next object that we are going to look at is a cone. We are talking about cones right after talking about cylinders because there is a neat relationship between the two objects. Suppose we had a cone and a cylinder, and they had the same diameter and the same height. If you fill the cone with water and poured it into the cylinder, how many times do you think you would have to do that before you would fill up the cylinder? It would take 3 times. Now there is a demonstration at this YouTube site here that you could watch. If that is the case, what do you think is the formula for the volume of a cone? Formula for the volume of a cone, we have the box here, which is we would take the volume of a cylinder and take 1/3 of the volume of a cylinder, which is 1/3 pi times the radius squared times the height. Now it says there is the same relationship between the volume of a prism and the volume of a pyramid with the same base. Okay, you could go and watch the demonstration here on YouTube. Now, it says the formula for the volume of a pyramid is 1/3 times the area times the height. Now we scroll down here. It says find the volume of the pyramid. So the volume is equal to 1/3 of the area times the height. So we will have the volume is equal to 1/3 times the length times the width times the height. It should be a capital H. Okay, so now we have the volume is equal to 1/3 times. The length is 8 centimeters. The width is 6 centimeters. And of course the height is 5 centimeters. So we have the volume is equal to, now we could take 1/3 times 6, which is 2. So we will have 8 centimeters times 2 centimeters times 5 centimeters. Now we can multiply this out. 8 times 2 is 16 times 5 is 80. So it's 80 cubic centimeters. That is the volume. Now we scroll down here to example 13, where we have find the volume of a cone. Okay, now the volume is equal to 1/3 of the volume of a cylinder, which is pi radius squared h. So the volume is 1/3 times, we can make pi into 3.14. The radius we know would be 4 centimeters. It's given in the figure, and that's squared, times the height, which is 9 centimeters. So the volume is equal to 1/3 times, we had 3.14 times 16 centimeters squared times 9 centimeters. So we have the volume is equal to, now remember we could take 1/3 times 9, which is 3. So it would be 3.14 times 16 square centimeters times 3 centimeters. So yeah, the volume is equal to, when you multiply everything out, it gives you 150.72 cubic centimeters. And that is your volume. Okay, now we have example 16. We have composite shapes. It says many odd shapes are just shapes we know put together. Consider the window to the left from an old bridge. Suppose the window had the dimensions shown on the right. What would the area of the window be? Okay, now we will have the area, oh, so this is giving some technical difficulties. Class, with this video here, this last problem we were doing, for some reason everything was disappearing. So I typed a lot of this information. For this figure here, we will have two shapes. We're going to do the area of a rectangle, which would be this full shape here, and the area of the trapezoid, which would be this top figure here. So we know the area of a rectangle is length times width, and then we add half of the height times the larger base and the smaller base. Okay, now we substitute. The length is 7 and the width is 5, plus half of the bottom base here, well, it's supposed to be half of the height, which is 2, and the bottom base here is 5, because this is the same length as this base here. So this would be 5 feet. So it would be 5 feet plus the smaller base, which would be 3 feet. So now we will have 7 times 5, which is 35 square feet, plus, now we look here, this would be half of 2, which is 1. And this would be 1 times whatever comes out of this parenthesis here, which is 5 plus 3, which is 8. So it would be 8 feet times 1 feet, which is 8 feet squared. Now, when we add the two values together, 35 feet squared plus 8 feet squared will give us 43 feet squared. And that would be the area of this composite figure. Now, we scroll down here to the next figure here, which is B. It says the picture on the left shows a normal window. Consider the normal window to the right. What would the area of the window be? Now, I was able to write in a couple things here. Hopefully it does not disappear. So we will have the area of a rectangle and the area of a semicircle or a half circle. We have length times width for the rectangle plus half of the area of a circle, which is half of pi radius squared. So the length is 5 and the width is 4. So we have 5 times 4, which would give us 20 square feet. Now for the area of a semicircle, we have half, pi is approximately 3.14, and then the radius is 2. Because remember, from here to here is considered to be the diameter, and we would take half of it, which would give us 2. So we have 20 feet squared plus 1/2 times 3.14, and 2 squared is 4. So we'll have 20 feet squared plus half of 3.14 is 1.57 times 4 square feet. So we will have 20 square feet plus 1.57 times 4 is 6.28 square feet. So when we add them together, we would get approximately 26.28 square feet. Okay, class, for the next few examples, I have the problems already worked out because for some reason I'm having technical difficulties and I don't want everything to disappear. So we could go through this step by step. We have example 17a. It says find the area of the label on the can of beans, assuming that it does not overlap. So we have the surface area. We have the surface area is equal to 2 pi times r squared plus 2 pi times rh, because we have the surface area of the two circles, and we have also the surface area of the rest of the cylinder. So we will have 2 times 3.14, and the radius, we'll take half of this 3.0, which is 1.5, and that's squared, plus it'll be 2 times 3.14 for pi. The radius is still 1.5, and the height is right here, which is 4.5 inches. Now when we multiply all these values here, we're left with 14.13 square inches, plus we will multiply these values here and we will have 42.39 square inches. When we add the two values up, we will have an approximate surface area of 56.52 square inches. Now we scroll down to B. We have the volume. It's the volume of 1/3 of the area times height. Now the volume is equal to 1/3. We're taking the area of the triangle in the figure. So we'll have 1/2 of base times height. Now if you look down here, here's your triangle. This is your base and this is your height. So now we have the volume is equal to 1/3 times 1/2 times the base is 19 and the height is 17. And we also multiply it by the other height, which is this 23 centimeters. So we have the volume is equal to 1/3 times 1/2 times 19 times 17 will give you 161.5. And all of that is multiplied by 23. When you multiply all of this out here, it gives you an approximate volume of 1,238.7 centimeters cubed. Now these were some interesting problems here, and so we need to move on. But there is one little correction here. This 1 had disappeared. It's supposed to be 1,238.17 centimeters cubed. Okay, now we go down here. We have C. It says find the volume. Now we're finding the volume of this upside down. Well, actually it's not upside down, but it is a cone. Okay, so we have the volume of 1/3 pi radius squared h, because it's 1/3 of a cylinder. So it'll be 1/3, pi will be approximately 3.14. The radius, as you see here, is 5 centimeters. So we will have 5, and the height is 13. So we have 1/3 times 3.14, 5 squared is 25, and 13. So we will multiply this out here. We will have 1,020.5 all divided by 3. So after we divide this by 3, we have an approximate volume of 340.17 centimeters cubed. Now we move on down here to D, where it says find the volume. Now what we have here is a pyramid over a rectangular prism. So we'll take the rectangular prism, which is length times width times height, plus 1/3 of the area times the height, which we did for the pyramid. So the length is 20, the width is 20, and the height is 60. So 20, 20, 60. And that will give us 24,000 cubic feet. Now we have 1/3, and we have the pyramid. Now we have the bottom of the pyramid is in a rectangle. So it'll be 1/3 of the area of a rectangle is length times width. And if you notice here, our length and width is the same size. So it'll be 20 times 20. And then our height, as you see here, is 21. So now we have 24,000 cubic feet plus, when we multiply this 1/3 by these three values, we will end up with 2,800 cubic feet. So 24,000 plus 2,800 cubic feet will give you 26,800 cubic feet. Now we move down here to E. We have the volume. We have 1/3 times pi radius squared h plus pi radius squared h, because we have a cone over a cylinder. So now we did the cone first, and then we did the cylinder here. So it'll be 1/3 times pi, which is 3.14, times 12 squared, which is our radius. Now remember, our radius is half our diameter. And we also have 6 feet here, which happens to be our height. Now if you look here, from here all the way down here to the bottom is actually supposed to be 16. Oh, I made a little error here. This height here is supposed to be 9 feet. So I need to make one quick little change. Okay, class, again with the technical difficulty, this 6 was actually supposed to be 16. The 1 had disappeared. So we will multiply this out here with the 1/3, and that gives us 2,411.52 cubic feet. Plus, when we multiply this out here, that's 3.14 for pi. The radius is 12, and then the height here is 9 for the cylinder. So we multiply this out, and it gives us 4,069.4 cubic feet. And we add these together, and our total would be 6,480.96 cubic feet. Now we have objective 4, solve problems involving the angles of triangles. The angles of a triangle. The sum of the measures of the three angles of any triangle is 180 degrees. So for it to be a triangle, when you add all three angles together, it must equal 180 degrees.